The race is on. To colonize the moon. To uncover hidden riches. And discover if humanity can really survive on another world. That's why we're going back. Not to visit, to stay. The moon is suddenly the center of attention, a magnet for minds and money. China, Russia, and the European Union have each sent probes and orbiters. In 2013, the Chinese landed a rover. Their goal, astronauts living and working on the moon by the 2030s. And they are not alone.
We will return American astronauts to the moon.
The moon will teach us how to explore the stars.
The moon is close. We can go there and develop the concepts and the technologies. We can figure out how to live off the land. We can figure out how we're going to do that only 3 days away. Then we can go on to Mars, where it's a tougher thing to do.
The moon is definitely a stepping stone to Mars and other places, but it's a world of its own that is also full of resources that we didn't know existed. The moon is Earth's 8th continent. It's like the New World, like the Americas were to the Europeans during the first explorations. It's an 8th continent for us to explore.
Like the Americas, this new world has deposits of precious metals, gold, titanium, aluminum. And there's a hidden treasure, first discovered in soil brought back by the last astronauts to walk on the moon.
We leave as we came, and God willing, as we shall return, with peace and a hope for all mankind.
In 1985, engineers at the University of Wisconsin studied the soil sample and found significant amounts of the isotope helium-3, a rare variant of the helium gas used to fill balloons on Earth.
A lot of people ask, what's the treasure on the moon? Is it helium-3? Helium-3 is very special because it's a potential fuel for fusion technology.
Helium-3 is rare on Earth because it's created by the solar wind, which is largely blocked by our atmosphere. It can fetch several $1 million per pound, one of the most expensive substances known to man. But the moon, without an atmosphere, could contain 1 million tons of helium-3, enough to power the Earth for 10,000 years. An unlimited source of power, and unlimited power for whoever masters it. So returning to the moon isn't about planting a flag and leaving a boot print. This is colonization, and that's a 2-decade process. Step 1, develop powerful rockets that can make regular round trips, rockets that cost a small fraction of current launch systems. This allows for Step 2, send a swarm of remote-controlled robots to prospect for water and build primitive habitats. Habitats that can withstand meteors and cosmic radiation, and temperatures that lurch from above boiling to twice as cold as Antarctica. Step 3, shuttle humans for increasingly longer stays on the moon, while avoiding suit-piercing space dust and enduring 1/6 gravity that leaches away muscle and bone mass. Step 4. The lunar outpost becomes a colony. It ships valuable raw material back home and makes Earth-bound investors rich. If nothing goes wrong along the way.
This is a tough place to get to. It's a tough place to stay, and yet that's our goal. There's a tremendous amount of wealth that we can create there, and there's a tremendous amount of resources that we can bring back.
Returning people to the moon depends first on overcoming one of the 4 fundamental forces in the universe: gravity. To get anything out of Earth's gravity well and past low Earth orbit, you need to push that object to escape velocity, 25,000 miles an hour. To build a colony on the moon, you have to get...
So on the way to the moon, now you've got a command module, a service module, and the lunar module.
Today, NASA is spending billions building a new super heavy lift rocket, the Space Launch System. And in early 2018, Russian President Vladimir Putin signed off on plans for a giant rocket to be built and tested by 2028. Super and giant rockets, all destined to be used once.
It's like you build a 747 for $1 billion, you fly it to Hawaii, and you throw it away. Then you build another 747, fly it back, and then you throw it away. That is not sustainable. It's too expensive.
Aerospace scientist, astronaut trainer, and ultramarathoner Eric Seedhouse has written a dozen books about commercial spaceflight.
Columbia, this is Houston, over.
He knows just how expensive a moon mission can be.
We'll see him right on the other side in orbit.
Roger, 762255.
Today we spend $10,000 to get 1 pound into low Earth orbit. You can probably multiply that by 5 to get it to the surface of the moon, at least.
And as the saying goes, no bucks, no Buck Rogers. So the challenge is getting to the moon without going broke. What if, instead of letting the first stages of a moon rocket drop into the sea, you could bring them safely back to Earth and use them to launch again and again? It's a problem that billionaire space entrepreneurs like Elon Musk are pouring billions of dollars into solving.
The launch business is a very competitive business, and they want to reduce costs to compete. To reduce those costs, you need to land those first stages.
You try it, you build it, and try it. If something goes wrong, you build it and fix it and try it again. Elon blew up 3 rockets before he got the 4th one right.
Each time SpaceX safely returns a reusable rocket to Earth, each time they prove their technology using a larger, more powerful rocket, humanity's return to the moon edges closer.
Companies, including Elon's, are going to bring the price down. Once we get the price down, there's going to be an explosion of stuff and people wanting to go to the moon.
Strapped in atop a reusable rocket, the first moon colonists prepare to launch.
2, 1, 0. We have liftoff.
The first crew to begin colonizing the moon won't be landing in an empty area. The robots will be waiting for them.
It doesn't begin with humans. It begins with robots. It begins with rovers.
In the years leading up to the first human arrivals, a fleet of reusable rockets has already ferried dozens of robots built on Earth to their new workstations on the moon. Bob Richards wants his robots to get there first, to kickstart a mining operation that will support a lunar colony. His space mining company, Moon Express, is headquartered in the shadow of the launch towers that sent men to the moon decades ago.
To think back to the inspiration that brought me here to Cape Canaveral, I'd have to go back to my childhood, my earliest memories as a little boy, walking around the rocket garden at the Kennedy Space Center. I was a child of Apollo, believing that the future was limitless. So I really believe that my DNA was set of exploration, and what an honor it is to be here in this hallowed ground where the first exploration of the moon and the solar system began.
Richard's ambitious plan begins with the launch of an autonomous lunar lander.
We're looking at the MX-1 robotic explorer. It's a robotic spacecraft that launches from Earth on a commercial rocket, and once released into Earth orbit, can light up its main engines and fly to the moon.
Richards and others are eyeing the moon's south pole as a good place for humanity to put down roots.
There are soaring mountains and valleys that would make the Grand Canyon look like a tributary. It's hard to land there. But on the tops of some of these mountains and some of the rims of some of the great craters that are there are very unique pieces of real estate on the moon. We call them peaks of eternal light.
The Earth tilts 23.5 degrees on its axis. That's what gives us our seasons and 6-month periods of light and dark at our poles. The moon is tilted only 1.5 degrees. Areas near the equator get alternating 2-week periods of light and dark. But the polar peaks are bathed in sunlight more than 90% of the year, and dark times are never more than 5 days long. A great place for robots that run on solar power.
So what it gives you is continuous energy from the sunshine. And our goal is to set up our first lunar outpost, a robotic outpost with a robotic explorer, land on one of these peaks of eternal light, and start prospecting for the elements that are there.
The MX-1 has thrusters, so it can hop from place to place on the lunar surface, where the gravity is only 1/6 as strong as Earth's. And it's designed to collect samples, then fly them back to Earth for further analysis.
Like any new frontier, it's not going to be easy at the beginning. And the robots hopefully won't complain too much.
The first robot prospectors won't be looking for helium-3. Instead, they're on the hunt for something more familiar, but potentially just as valuable: water.
In the time period of Apollo, we thought it doesn't have any water.
Magnificent sight out here. Magnificent desolation.
We were wrong. Boy, were we wrong.
It turns out that hydrogen from the solar wind bonds with oxygen atoms locked in the lunar rocks to create H2O. Maybe several billion tons of it.
That's billion with a B. The water becomes the gold of space. Instead of the gold rush days to Alaska, it's after the water.
If Richards can extract water from the moon, it will save the enormous expense of hauling it from Earth, not just for use as drinking water, but as a lucrative source for rocket fuel.
Separate the water into its elemental pieces, hydrogen and oxygen.
Cool the hydrogen to just below negative 423 degrees, and it becomes a liquid, liquid hydrogen.
That becomes rocket propellant. It's the most powerful rocket propellant we know today.
That's where the real money is. Lunar refueling stations, where customers like SpaceX and NASA will pay top dollar for the liquid hydrogen they need to get back to Earth or elsewhere in the solar system.
Water is like the oil of the solar system, and we're after our first gusher.
The next wave of millionaires and billionaires, just like we had the oil billionaires of the past, will be the water billionaires of space.
And this is how it all begins. A crew of 4, completing a journey not taken since the 1970s. They're here to make the moon into humanity's first permanent home on another world. And from the first small step, survival is a constant challenge. Imagine talcum powder made of broken glass. That's the lunar soil known as regolith, and it eats spacesuits for lunch.
On the Apollo 17, the seals on the pressure suits were badly affected by the regolith, by the dust. They brought lunar dust into the lunar module. You get those small particles of silica deep in the respiratory tract, and it causes a lot of irritation.
The regolith isn't just hard and sharp. It's also radioactive. Cosmic rays bombard the moon every second. Looming over every colonist is the prospect of early death from radiation-related diseases.
It's a very harsh radiation environment, and spacesuits do not protect against radiation. Astronauts walking around the moon all the time in spacesuits, that's not going to happen.
That's why, when the first human colonists arrive on the moon, a shelter is already waiting for them. These astronauts are opening the door on a new era in human history. This is humanity's first home on another world. In 2015, the European Space Agency unveiled a visionary concept for a lunar village, inhabited by astronauts and robots from countries around the world. To prepare the colony, robots could be sent to construct habitats years in advance of the first human arrivals.
We can't take all the building materials from planet Earth. Concrete is kind of heavy. Rather than that, we want to use the material that's already there, the soil, the dust, and materials, and 3D print that into building blocks, bricks on the moon.
The robot-assembled habitat will support the colonists at first. But soon, a delivery arrives. The colony is about to expand. Inflatable fabric-shelled habitats are a logical solution to quickly adding more workspaces and living quarters to a moon base. But can any fabric stand up to the stresses of space? This man may have the answer. Maxim de Jong designs fabrics for space. Sometimes he tests them himself. De Jong's fabrics not only keep him up in the air, they are the key component of his prototypes for inflatable lunar habitats.
With an inflatable habitat, we can package it in the nose of a rocket. We can make it small. On orbit, it deploys. We can make it huge.
You pump air in it, and it blows up like an air mattress.
But this is more than a guest bed. De Jong's prototypes are made of Kevlar and other high-stress, high-impact materials. When fully inflated, like a pneumatic tire, the outside feels as tight and tough as a concrete wall. NASA designed inflatable space habitats decades ago. But the projects were abandoned along with the moon. In the early 2000s, hotel magnate Robert Bigelow bought the patents and developed them further. De Jong's company, Thin Red Line, helped design the first functioning inflatable habitats for Bigelow. A fabric structure like this Bigelow module on the International Space Station can weigh half as much as a metal habitat, so it takes less fuel and money to launch it into space. And it can be compressed to half its width. That frees up payload space and also saves money. At Thin Red Line's headquarters in British Columbia, de Jong is working to perfect his habitats for deployment on the moon.
When it comes to the extended stay, 6 months or longer, on the lunar surface, it can't leak. This unit, for example, is using full fidelity, life support grade gas barrier, only one thin layer of 5/1000th of an inch. And yet this has been inflated at roughly the same pressure for 8 years.
To make sure they'll be safe for deployment in space, de Jong pushes his test habitats to the limit. But can future colonists really trust these habitats to protect them from every danger on the moon?
Out there in space, we have micrometeorite showers, and they come at you at speeds 10 to 100 times the speed of our high-power rifle.
Everybody thinks balloon is going to pop.
In reality, the shell of the habitat acts like a bulletproof vest, distributing the energy of the impact through multiple layers of high-strength material.
A micrometeoroid hits it so hard that it basically almost vaporizes.
De Jong is confident that in the near future, his designs can be safely deployed on the moon.
All right.
Although, on the moon, safety is never guaranteed. Sometimes the surface is rocked by earthquake-like tremors called moonquakes. No one knows how they're caused or when they'll strike. but these quakes can reach 5.5 on the Richter scale and can go on for 10 minutes or more. And there's a danger that's even more destructive. See those craters? They're not all billions of years old. Just in the last few years, several meteors have hit the moon so hard, the impact was seen on Earth. A 90-pound rock can slam into the moon with the force of 5 tons of TNT. To ensure long-term survival, at least some of the colony will need to be located underground. Orbiting space probes have found more than 200 tunnels under the lunar surface, with natural entrances called skylights. They are lava tubes from long dead volcanoes, similar to ones found on Earth.
We have lava tubes in Hawaii all over the place. They run 20 or 30 miles. Some of the ones that are here are 15 feet in diameter.
Thanks to the moon's 1/6 gravity, some lunar lava tubes can be even bigger. A Japanese orbiter recently discovered a skylight leading to a lava tube big enough to hold the city of Philadelphia. There are also lava tubes on Mars, so if we can learn to live in them on the moon, it will pave the way for future colonization of the red planet. But before you can build a habitat in a lava tube, you have to fully explore and map it. And the futuristic technology to do that is being developed in a surprising place. America's former industrial heartland, Pittsburgh, Pennsylvania. By a company headquartered in what was once a steel stamping facility, Astrobotic. Unlike the older generation of space racers, CEO John Thornton wasn't inspired by men, but by machines.
I still remember the Mars Pathfinder landing on the surface of Mars, and I was just awestruck. I remember in the 5th grade, my teacher assigned a project to build something relating to the news, and I chose the Mars rover, and I built a little Lego model of that.
Thornton is overseeing several next-generation lunar probes, including a drone that can fly by itself through a skylight, explore a lava tube, and report back on whether it's suitable for human habitation.
Flying a drone in and out of a cave is very, very challenging because of the high-speed nature that's involved and the amount of computing that's required and the sensing that's required.
They're testing the guidance system on a custom-built propeller-driven drone. But the final version won't be able to use propellers.
There's no atmosphere on the moon, so propellers won't work. So the propulsive means on the surface of the moon will potentially be a cold gas propulsion system or some other chemical means to get in and out.
Drones will need to guide themselves. But how can they do that in total darkness? That's the other major problem Astrobotic is tackling.
My group is working on a very small propulsive vehicle. Sometimes we call it BatBot, because basically you're giving the machine the capabilities to navigate in the dark. So our concept involves a lunar lander. This lander would land close to the edge of the skylight, and once it landed, it would deploy a smaller spacecraft that would be capable of exploring this lava tube. Once you're inside, you're GPS denied. You won't know what it looks like before you get there, and it's also going to be extremely dark.
That means BatBot will need sensors connected to AI to register the tube's twists and turns.
Make sure it doesn't run into walls, detect areas that it could possibly drill for resources or find resources inside a lava tube. We send the data back to Earth, and we could start to plan how to build a colony inside this lava tube.
But even this won't protect colonists from the moon's most insidious danger. The way its 1/6 gravity eats away at the human body, leaching away bone and muscle mass. Lunar colonists exercise at least 2 hours a day, or they'll become too weak to work. And living underground taxes the minds of the colonists, who have flown 250,000 miles to find themselves cooped up inside a cave.
I think we should build 2 moon bases, one on the north and one on the south.
How we'll live on the moon in the long term, not just survive from hour to hour, is a key problem being tackled at the International Moon Base Summit in Hawaii.
Which one first?
What we all believe in is that the giant leap, the foundations are being laid right here.
It's a gathering organized by Dutch visionary and entrepreneur Henk Rogers, the man who brought the video game Tetris from Russia to the world. Now, he wants to bring humans back to the moon.
I believe that to survive in space, to survive on other planetary bodies like the moon and Mars, we have to create the most amazing spaces that people have ever been in to make it attractive. There's got to be a kitchen.
Of course, yes.
It can't just be like a replicator or whatever. That's something that spits out meals ready to eat.
You're absolutely right that the human being first needs to feel comfortable.
My plan for that is to have windows in the underground structure that look out into fake scenes of Earth, just like in a flight simulator. So I would put cameras on Earth and record a week's worth of someplace, and then play that in all of the windows of the moon base.
With a safe and sizable habitat established underground, the base grows. The initial group of 4 astronauts is now a settlement of 40, each working on the moon for a year before rotating back to Earth. As the moon base enters its 2nd decade, the human colonists spend most of their time underground, while robots work 24/7 above ground. With billions to be made, control of these robot miners is the key to the moon's treasure. At the headquarters of the European Space Agency in the Netherlands, engineers are developing ways for astronauts to prospect the lunar surface by remote control. They've experimented with advanced joysticks, but more complex maneuvers require a closer melding of man and machine. This is the Sensory Arm Master, or SAM, an exoskeleton with sensors at each of its 7 joints that transmit precise movements to a robot arm.
It's designed in a smart way,
Exactly.
right? And there's also a more direct correlation between your shoulder, your elbow, the hand, and the shoulder, elbow, and hand of the robot, right?
Yes. And I can also receive the force feedback from the robot on all the joints.
Force feedback sensors on the arm give the robot a sense of touch that the controller can feel.
There's also safety attached to it. Like, if I have a stuck rock here, if it's stuck like that, I don't know how big it is, right?
Mm-hmm.
So I pull on it and nothing happens. Perhaps I want to stop pulling on it before this thing snaps, right?
Exactly. So you actually get a sense of touch, and this is the power of the human in the loop.
With this technology, lunar astronauts are firmly in control and out of harm's way.
You're going to be living in the bunker, operating the robots by remote control. You won't be doing long excursions on the surface of the moon.
For those hoping to strike it rich on the moon's helium-3, the highest soil concentrations are only 50 parts per billion. We might have to excavate more than 200 square miles of the moon to get enough to power all of the United States for a year. That's one reason China is interested in exploring the far side of the moon. It's exposed to more solar wind, which might have created higher concentrations of helium-3. China estimates the moon may have enough helium-3 to take over the world's entire electrical grid for the next 100 centuries.
You have to process a lot of regolith to get a little bit of helium-3, but it's potentially a game changer.
For the colonists, it will be a non-stop struggle to keep the mining robots operational.
On the moon, the dust is electrostatically charged, which means it's more likely to stick to our robots and our cameras and our solar panels as we operate on the surface. Humans can wipe dust off with their hands, but typically robots aren't designed to do that. So we are worried about the dust accumulating on the surface of our robots over time and reducing our ability to operate.
The contrast between day and night doesn't make things any easier on the robots.
At night, the temperatures are liquid nitrogen cold. During the day, they're as hot as a low temperature oven. And electronics, batteries, and even mobility components like drivetrain components are challenged to survive that.
If replacement parts can't be assembled or 3D printed on the moon, they'll need to be delivered. The colony's survival depends on a reliable delivery system between the Earth and Moon. On Earth, delivering a spare part or any other package is routine, thanks to reliable vehicles guided by GPS. That kind of infrastructure doesn't exist on the Moon. But that's what the team at Astrobotic is building.
This is Peregrine, our lander. This is the delivery vehicle that will carry payloads up to the surface of the moon. So payloads attach above and below this deck right here. So some rovers will attach underneath and drop down to the surface. Some payloads will stay attached on top of the vehicle. We have 12 small attitude control thrusters scattered all over the vehicle, high and low. These are used to orient the spacecraft in space. So we use that to make sure that the spacecraft is pointed in the correct direction. We have 5 100-pound force engines that provide the thrust to slow the vehicle down as it approaches the surface of the moon.
For lunar deliveries to become routine, Thornton needs his fleet of delivery vehicles to land autonomously. On Earth, you can use GPS to automatically position a spacecraft for a precise landing. But on the moon, there are no GPS satellites. So, are autonomous landings even possible? Thornton is about to find out. This is the first full test of Astrobotic's landing guidance system. It uses cameras to scan the surface and match the features it sees to onboard maps stored in its memory.
What that allows us to do is our spacecraft can navigate down to the surface of the moon and know where it is at all times.
Once it locates the intended landing area, it's designed to automatically reorient itself to avoid hazards, like the rocks strewn across this desert landscape.
As we're descending down to the surface of the moon, that same technology can be used to look for rocks and obstacles and slopes that might interfere with a safe landing.
If this test succeeds, it will be the first time a free-flying rocket-propelled vehicle has landed autonomously without the aid of GPS.
Our sensors were looking out over the field as we were descending. That means that we can do landings on the surface of the moon to very precise spots.
While some delivery vehicles will be launched directly to the moon, others will bring their cargo to a point in space about 38,000 miles beyond the far side of the moon. This is a Lagrange point, named for an 18th century French mathematician. It's one of a handful of areas between the Sun, Earth, and Moon where gravity is basically balanced.
It's a gravity neutral point. So if you can go there, you don't need a lot of fuel to stay there, and you stay at the same point over the moon instead of going around and around.
The Lagrange point becomes a way station in space, a place to store fuel and supplies, and for cargo deliveries, a port of entry, where it takes only a small amount of thrust to get down to the lunar surface. The delivery of the much-needed replacement part means a rare opportunity to step outside.
Every once in a while, we'll send the astronauts out to do a repair mission.
The repair mission has to be fast. Radiation exposure needs to be kept to a minimum. And there are less predictable dangers. A moonquake, 5.5 on the Richter scale, and there's nowhere to run.
A 100 years ago, in the heroic era of Antarctic exploration, when people died, it was just an accepted part of exploration. accept the fact that people will die, and that's the price you pay.
In space, death is the cost of doing business. And as long as money can be made, the colonizing will continue. Mistakes will be learned from. Technology will advance. Stronger habitats and spacesuits will be built. Risks will never be eliminated, but they'll be reduced. If the moon is the 8th continent, then it'll be developed like one, with an eye on the bottom line and the expectation that today's $330 billion space industry is only the beginning.
What we want to do at Moon Express is move the economic sphere of Earth outward from Earth orbit to the moon. And that will transform our society and benefit everybody here on Earth.
By the end of a century, what started as a primitive moon base has grown into a colony where dozens of people live for more than a year at a time. And the first colony has been joined by others: a European village, a Russian base, a Chinese mining operation. Each colony mines helium-3 and ships it to Earth, providing energy to millions and a fortune to investors. And each mixes moon-made propellant and flies it to depots parked at a Lagrange point to refuel rockets headed for Mars. The moon is now a stepping stone to other planets.
The moon is the place we're going to go to extract resources and turn that into usable things for us, to refuel our spacecraft and go deeper into space. So the moon is our gateway to our solar system.
It's the stepping stone. We have to become a multi-planetary species. For safety reasons, for lots and lots of reasons. If humankind wants to expand, we've got to get off this planet.
It's this epoch right now where all future generations of humanity will look back and say, this was the time that we moved out to space permanently.